Hi. Hi, good afternoon, everyone. Thank you for the invite, and thanks for the hospitality. I look forward to meeting everyone personally once I have the opportunity to. My name is Michael Brown. I'm the founder of Cloudnine AI, and what we've done is basically create a platform for our healthcare enterprises to trace their data with glass box traceability. So many of the issues that these organizations have with using the current black box AI is that it's opaque. There's hallucination issues. Anytime you enter in any type of complicated data, you have several problems with transparency. So we decided that from the ground up, we're going to build an architecture with a glass box instead of a black box. And so the company's been around we were founded in 2020. My background in healthcare began during the deployment of Obamacare, the ACA. I was part of the integration teams that work with payers and providers. And what I understood from during these integrations is that every state has their own data governance and data privacy issues that you have to comply with. And so when we designed our architecture, we wanted to make sure that we were in compliance, not only with Medicare or Medicaid, but any type of state requirements, whether you're a life sciences company, payer, provider, anyone in the healthcare space. And so that's what we started from scratch. We've introduced our flagship product, which is REL 1, and that's what we've introduced to several healthcare companies currently. This is our core team. Everyone on the team has at least 25 years of experience. This is a very complicated problem we're trying to solve within the healthcare space, and so I've brought on a team of experts throughout the industry. My co-founder, he comes from organizations like World Health Organization, and so he understands data compliance at a global scale. And the problem with any organization is context. The amount of data that they've been collecting for the last 100 years, as some of our clients, is trying to contextualize some of the data that they've been collecting. The use cases that they've had in using large language models, they've had to manually manipulate the data in order to add context to the information. And the challenge that you have is the amount of data that any of these organizations have been collecting, it's impossible to maintain the context with any of the data that they've been collecting. So you've seen very modest results from any organization. They've been deploying large language models for a while, and they've been using it. And based on the amount of data that they've been collecting, every executive is going to tell you that it's not enough. There's way too much data, they're collecting way too much information, and they have the biggest hurdle that they have, compliance issues, not only regulatory requirements for the US, but also global requirements, whether it's in Europe or manufacturing their products in India. So the core of the problem is the rigid infrastructure, the underpinning infrastructure that they're using. Think of things like Oracle databases, vector database. They all have what we call rigid schemas. And at the core of that problem, these rigid schemas require these organizations to follow a workflow that's just impossible to manage. And so all of these rigid file structures create inherent problems, not only resource intensive, but also expertise intensive. And so what we've done in creating our platform is that it eliminates all of those problems. You don't have any resource intensive problems. You don't have any expertise problems that are required as well. And so the way that we organize the data is that we organize it based upon, as I mentioned, context on what the data means. And so all our platform needs is access to the physical data. Now, what's important to maintain that we're in compliance with any enterprise, the physical data remains the same. It's never impacted. It always remains the same. What we've created is a virtualization tool that virtualizes that physical data so anyone within the organization can model that information and you can control access to that data. And you don't need the technical expertise to be able to use the information and have access to the data. We actually built this for what we call researchers and scientists that don't need to have a great deal of expertise, and you don't have to have a great understanding of prompting. You don't have to know what you're looking for within the data. So basically the comparison with, as I mentioned, with black box architecture, there's a lot of dependency on model training. You need a lot of data and you need a lot of expertise in terms of training that model. And also training that model requires a lot of energy. And so we're avoiding all of that. We're automatically ingesting the data, as I mentioned, virtualizing it, so you eliminate any type of model training. So that's a huge lift for a lot of organizations. And we're not energy intensive, meaning that the architecture we're utilizing the existing memory that's currently in these systems generate enough energy for us to actually augment them and run the models within those systems. The other component is that we're not a black box infrastructure. As I mentioned, we're a glass box. Everything is transparent. We have to have proof. You have to know the root cause, and you have to give everyone access to be able to view the information. And then in terms of, as I mentioned, prompting, there's no prompting. You can ask any question that you want. The question doesn't have to be complete. It can be in any language that you want. And so that's the beauty of the architecture that we've created. And this gives you a quick snapshot of RHEL 1. It's basically a glass box layer. Any of the data silos for any organization remains intact. Data automatically is ingested from any data source, regardless of its structure or format. And then it's virtualized. Once it's been virtualized, then you can share that information with anyone that you want to have access to, whether it's internal or external resources as well, and then share that information across the organization. So the purpose of doing this for these enterprises, such as Becton Dickinson and Edwards Life Science, is that when they've acquired the other organizations, there's no way to aggregate that data. When you acquire another organization and they have different legacy systems that were built at different times, they've collected so much information, there's no way to aggregate it in a simple way, and also to be able to govern it. Because Becton Dickinson is a global organization, they have to govern the data based upon US requirements and also Europe and India. So this gives them the flexibility to do that without acquiring a lot of hardware resources. So as I mentioned, we're just breaking down silos, breaking down data sources, and turning them into basically a glass box. It's an explainable tool, so you can see the root cause, and it's secured and it's classified by the Department of Defense as impact level 6 compliant. That's the highest level of compliance you can achieve with the military, so it meets a DoD level grade of security. And so any type of personally identifiable information is automatically removed from any type of data once before the ingestion process. And how does it work? Basically, as I mentioned, we're just ingesting the data from any data source, whether it's a relational database, vector database, or a graph. We're virtualizing and unifying all the data into one unified system, and then we're resolving any type of data quality issues, meaning that any duplicate data is automatically deduplicated, or if you have any type of errors in that data, those type of issues are automatically resolved as a part of the architecture. Any organization that wants to customize it, like we have, like I mentioned, Becton Dickinson, another healthcare company is Fresenius Kabi that does the kidney dialysis. Every one of Fresenius's clinics across the United States has to follow a different Medicaid requirement, and so we're customizing it for them in those requirements. And then basically, once you're digitizing any type of data, every point of data becomes its own data source. You basically have metadata from data, and then you're able to transition in terms of traveling back in time to the data. So at any point in time, you can view the data, whether it's data that's viewed today, 30 days from now, 30 days ago, or even 1 year ago. You can actually view the data at any point in time, and it's bidirectional for any user. And so this is basically showing just a cognitive leap forward in using the architecture. The architecture is proprietary to our organization. We're using an associative architecture, and that's why we're able to provide the explainability that the current black box architecture can provide. It's also a customized memory, so it eliminates any type of hallucinations that you'll find in the current black box models. And so we're that intelligence layer that's between any type of database or data sources, but we're viewing ourselves as an augmentation tool, augmenting data, also augmenting any type of scientists or researchers as part of that integration process. And what we're looking for currently, we're looking for any type of partnerships, any type of pilot programs. We built this enterprise product specifically for BD and for Fresenius Kabi. However, we also have a lightweight model that we've just released in beta test that we can put in anyone's hands currently. It's almost like a freemium that I'm willing to offer and looking for partnerships for someone that'd like to try it as well. But that's it. Thank you.